In this video, I'll be going over examples of finding the unit tangent vector and the principal unit normal vector. For this one, find those for r of t, which is equal to the vector with components 6 cosine t, 2 sine t, at the time t equals pi over 3. You can pause the video now and work on the solution to this, and then come back to the video to check your solution. Now what I've done here is I've sketched the graph of the path of r of t using the parametric mode on the graphing calculator, entering x equals 6 cosine t and y equals 2 sine t. If we want to find the unit tangent vector, we do that by taking r prime and dividing by the magnitude of r prime. So r prime, the derivative of the vector, the derivative of 6 cosine t is negative 6 sine t, and the derivative of 2 sine t is 2 cosine t. We're going to divide that by the magnitude of that, which is each component squared, added together, and take the square root. So when you square the first term, you get 36 sine squared t, and square the second component, you get 4 cosine squared t. So we can simplify this a little bit for our unit tangent vector. The numerator will keep as the r prime of t, but the denominator can be simplified. We have 36 sine squared t plus 4 cosine squared t. If we take out 4 sine squared t, then we can use the identity of cosine squared t plus sine squared t. So we're going to take out 4 of the sine squared t, and that will give us 4 sine squared t plus 4 cosine squared t, and that will equal 4. And then what we have left over after we took out the 4 would be 32 sine squared t. So that just simplifies the denominator a little bit for us. Now we want to find the unit tangent vector at the given time t equals pi over 3. So we plug in pi over 3 into p in the numerator and the denominator. And then when we simplify, the sine of pi over 3 is the square root of 3 over 2 times the negative 6. That gives us a negative 3 square root of 3. And the cosine of pi over 3 is a half. So 2 times a half is 1. So our numerator is negative 3 square root of 3, comma 1. The denominator would be the square root. Again, the sine of pi over 3 is the square root of 3 over 2. When you square that, you get 3 over 4 times 32, and then add 4 to that. You get the square root of 28. Now the square root of 28 can also be simplified, and the square root of 28 is 2 square root of 7. So we have negative 3 over the square root, that should be square root of 3, over 2 square root of 7, comma 1 over 2 square root of 7. That's the components of the unit tangent vector at the time pi over 3. Okay, again, that can be simplified to, as a decimal, it's approximately negative 0.98 and 0.19. The components of the vector are approximated here using decimals. I just wanted to clear that up, that should be a negative 3 square root of 3. So that is our unit tangent vector at the time t equals pi over 3. Now if you locate that position of the original position at t equals pi over 3 on the graph, let's use a graphing calculator for that. Here I've already used the y equals in parametric mode and entered the original position vector valued function. And when I graph it using a standard zoom, I adjusted the window a little bit, but you'll see the graph. I'm going to trace and locate the position at t equals pi over 3. And you'll see that that is the position on the path at the time t equals pi over 3. So from that position, we're going to be sketching the unit tangent vector with components approximately negative 0.98 and 0.19. And since I have the graph over here, I'll go ahead and sketch that on the graph. So it's approximately here, the location. I'm going to move negative 0.98 almost almost -1, up 0.19, just a little bit. So that is our unit tangent vector. It should be tangent to the path at that specific point. Now to use the graphical shortcut to find the unit tangent vector, we need to reverse the order and then determine which of the components would have the opposite sign. So our unit tangent vector is given here, and then using the principal unit normal vector shortcut at the time pi/3, we're going to reverse the order of the components. So one is going to be 0.9, the other one's going to be 0.98, but we're going to make the opposite sign. Going back to the graph, it should point towards the concave side of the curve. So in this case, it will point towards the inside of the graph, and those should be orthogonal, although you won't see that on a graph that's been stretched out. The scale is changed here. So a vector that's going down and to the left should have a horizontal component that's negative and a vertical component that's negative. So for the principal unit normal vector, both of those are negative.